Morning. This is a video for the activity related to the product rule. So the question is this: does the derivative of the product of two functions equal the product of the derivative of the two functions? In other words, right now I can look at this first parentheses as f of x and the second parentheses as g of x, and think of this equation as one function times another function. The real question that we're trying to get across is, does y prime equal f prime times g prime? So we can find f prime and g prime and work that out. So that's what we're going to do. So f prime, if we just look at f prime is going to be 2 minus 6x, and then g prime is going to be just 3. So multiplied together, f prime times g prime is going to equal 6 minus 18x. Okay, so if I take y and I expand it normally, and then I try to see if the derivative is the same, that's what we want to try to go for. So I'm going to distribute 2x times negative 4 is negative 8x. 2x times 3x is 6x squared. Negative 3x squared times negative 4 is 12x squared. Negative 3x times, or negative 3x squared times 3x is negative 9x cubed. So negative 9x cubed plus 18x squared minus 8x. If I take the derivative of that, use my take the derivative notation, I get negative 27x squared plus 36x minus 8. So I'm going to pause this and see if I made any mistakes. But if I didn't make any mistakes, then the derivative of the product, which is what is in red and black, is not equal to the product of the derivatives, which is what's equal in blue. And I think that makes sense if we just think about it from a degree perspective. Originally, we're taking a quadratic times a linear, so we got a cubic function, which is that red negative 9x cubed expression. The derivative of a cubic expression is a quadratic because the degree goes down by 1. If we take the derivative separately, our quadratic goes to a linear, our linear goes to a constant, and a linear times a constant is a linear. So just from a perspective of the degrees, that doesn't work. So what we want to do is come up with what is the rule to multiply two functions. I don't need it on something like this because I could just do what's in red and black. Just be clear, the blue did not work. I could just expand it, but if I had something like sine squared x times 2x plus 3, and I wanted to take the derivative of that function, that expression, I need to know how to do that. So we need to figure out a rule for finding the product, the derivative of two products, or the derivative of a product of two functions. All right, so I'm going to pause and pull up the activity. This is for the product sheet, so you can grab yours. It says, fill out each column in the table. You are investigating how to find the derivative of a function that is the product of two functions. For all sets, capital F of x is the function that we're working with, and that's going to equal these two smaller functions together. So the way this is designed is that between the 2 or 3 sets there are, you're going to fill in the boxes. So you're going to fill in this top row, then you're going to fill in underneath there and come up with a pattern. And that pattern's not going to work for all of them yet. So then you're going to do the second set and see if you can add to your pattern and then go from there. So I'm just going to, you need to pause right now and look over this and see if it makes sense, and then we'll touch base. Okay, so I'm going to kind of go through set 1, and you can, if you don't understand what I'm asking you to do, since I'm not there, you can just watch this as much as you need to and then pause and work out the rest. Your goal is to come up with a formula or a rule that we can use to make this happen, the product of two functions, find the derivative. So set 1, this is hard to see, but you have it on your paper. So f of x equals 3 of x So I'm going to go to f prime of x, which is over 2 boxes. F prime of x is just equal to 3. Right? The derivative of 3x is just 3. G of x is equal to 5. That's a constant. So the derivative of 5 is 0. On the left-hand side, it says capital F of x. So f of x is just f times g. So 3x times 5, or 15x. It's the derivative of that. If we just took it naturally, the derivative of 15x is 15. So in this bigger box, it says, can you determine a formula using f, g, f prime, and g prime as the parts in order to equal f prime? In other words, how do I use the red and the blue to make purple? So I have g of x equals 5. So that's 5 times f prime of x. So g of x equals 5, f prime of x equals 3, and capital F prime of x equals 15. And so using as few parts as possible, and it says that using as few parts as possible, that's my rule so far, g of x times f prime of x. So in set 2, if you try set 2, you're going to notice that this rule we just came up with isn't complete. It doesn't work all the way. So it just works for this example. So we need to see, well, there's 2 other parts I didn't use. I didn't use f of x. I didn't use g prime of x. What do I need to do to add to my rule? So if you've watched this or whatever, got to this point, go ahead and pause and try to complete set 2. All right, I'm going to work through set 2 so you can check your work, or if you got stuck. I'm actually going to do the left-hand side first. It says we're going to do f of x, which is x squared, and then times g of x, which is x plus 5. So together, that's going to be x to the third plus 5x squared. The derivative of x to the third plus 5x squared is 3x squared plus 10x. So now I'm going to work on the rest of this chart. So f of x was x squared, so f prime of x is just 2x. G of x is x plus 5. So the derivative of x plus 5 is just 1. So it says, can you determine a formula using those pieces in order to equal f prime? Start with your original formula from set 1. So my formula from set 1 was g times f prime. So g times f prime. So g was x plus 5 times f prime is 2x. So far that's going to be 2x squared plus 10x. So 2x squared plus 10x. I had 3x squared plus 10x, so I need another x squared to make that into 3x squared plus 10x, and that's what this is, f of x. So this x squared is my f of x. So my formula now changes to g of x times f prime plus f of x. Again, I used 3 of the 4 pieces. I didn't use g prime, didn't need to. You might be able to see how g prime works there. And if so, you can take a guess, and then let's go ahead and do set 3. Or you can pause, do set 3 if you haven't done so yet. So f of x is 4x squared plus 1. The derivative of that is going to be 8x. G of x is 3 times x to the third. So the derivative of that is going to be 9x squared. If I think about the function in general, f of x is capital F of x, 4x squared plus 1 times 3x cubed. So I can distribute that and get 12x to the fifth. So we'll have a plus 3x to the fourth. So my derivative will be 60x to the fourth plus 12x to the third. All right, so starting with the previous formula was g of x times f prime of x plus f of x. So let's see what that gives me. So g of x was 3x squared. F prime of x was 8x. F of x was 4x squared plus 1. And so if I look at this, I have the 8x times 3x squared gives me a 24x to the third. And then I have a plus 4x squared plus 1. So I need an x to the fourth from somewhere. Right? And the only part I haven't used yet is g of x, or g prime of x. And so if you had to guess, looking at it, I have g of x times f prime. Why not have f of x times g prime? See what that does. So this is 4x squared times 9x squared. So I have 24x to the third plus 36x to the fourth plus 9x squared. So that doesn't look anything like what I'm supposed to have. I mean, a little bit. So I need to go back and see where my mistake is. You probably already saw it. Up here in the original purple, I did 4x squared plus 1 times 3x cubed. Should be 12x to the fifth plus 3x to the third. So not 3x to the fourth. I'm going to change that. The derivative of that then would be 60x to the fourth plus 9x squared. That's helpful. And then the other mistake I made, and I can blame it on it being hard to see on the Smart Notebook, is that right here where this says 3x squared, that's really a 3x to the third. That makes this a 24x to the fourth. And so 24x to the fourth plus 36x to the fourth is 60x to the fourth plus 9x squared. So you probably got there more smoothly than I did since I made two mistakes, but it is 5:52 in the morning, so I'm going to blame that too. All right, so we have a product rule. You can see it there in red and blue. G of x times f prime of x plus f of x times g prime of x. And that works. So product rule, there's a limit definition process that's kind of interesting. If you will use, it should say delta x as delta x goes to 0. If you do f of x plus delta x times g of x plus delta x all over delta x, there's kind of a weird math thing you can do, which is to add and subtract the same term, like so it doesn't change anything. So that's what is in red. If I just randomly subtract this expression that I came up with out of nowhere and add the same expression, which doesn't change anything, you can go through some factoring and verify that it works. But ultimately, there is your product rule. That's the way that the product rule is written in your book, and it is not the way that I do the product rule. So you can do this, there's absolutely nothing wrong with it, but I prefer to rearrange it of f prime of x times g of x plus g prime of x times f of x. So I'm just switching these two. And the reason that I do it this way is because then it's easier for me to remember the quotient rule. So there's the product rule. You can look over some of the examples from the notes that are posted online and then go on to the quotient rule because this video is getting long.